Okay, hi everyone. So today we have another Codeforces round, and today is an educational Codeforces round. So yeah. Also, like I have dropped to expert, so the aim here will be to try to get back to candidate master, but I can only get back to candidate master if I perform really well today, because I need some like positive 110 delta. So that wouldn't be possible if I perform like normally or if I perform bad. But let me just test if Sublime is working fine. Okay. Also, I've reduced the quality of the video just a little so that my Sublime works faster, because nowadays OBS Studio is taking up a lot of memory or time, I would say. So yeah, like even by lowering the quality, I am getting some 3 seconds of compilation time, which is pretty huge. But let's see. I hope I do not get a very long compilation time during the contest. Like even though I have a pre-compiled bit/std c++.h header file. Okay. So, okay, problem A. 4 players participate in the playoff tournament. The tournament is held according to the following scheme. The first player will play with the second, the third with the fourth, and so on. The winners of the players will play with, okay, in the finals of the tournament. It is known that in a match between two players, the one whose skill is greater will win. The scale of the ith player is equal to SI, and all skill levels are pairwise different. The tournament is called fair if the two players with the highest skills meet in the finals. Determine whether the given tournament is fair. With the highest. Oh, okay. So we have int. So these are the max ones, and if max 1 is greater than C and max 2, okay, min of C comma D, and max 2 is greater than min of A comma B, then we're done, right? Okay, this seems to be fine. Yeah, come on. Okay, accepted. Great. Moving on to problem B. So you're given an array A consisting of n integers. Let's call a pair of indices I and j good if, okay, GCD of AI and 2AJ is greater than 1, where GCD is this. Find the maximum number of good index pairs if you can reorder the array in any arbitrary order. In any arbitrary order, okay. Great. So if we look at the first array, then by reordering it like this, we have okay, 1 and 2. 1 and 2 works because 1 and 4 works, right? So if 1 and x works, then what do I know? I don't think reordering in any way makes sense here. Actually, it makes sense because sometimes 2aj is not defined at all. Okay. So we have 1 and 2 which works fine. How are there 4 pairs here? 1 and 2, 1 and 4. Does 1 and 4 work? And GCD of AI and 2aj. Oh, okay, 2aj. Okay, I understand this now. Okay, I was wondering about I was like looking at the index. It was not the index, it was the actual number. Okay, AI and 2aj. So does the ordering matter? Like if I have a number and 2aj. Okay. Does the ordering matter? Because if I take aj, then it gets paired up with all the elements in the prefix, right here. Okay, let's pick up any number. So which number should I keep at the end? The one which gives me maximum number of pairs, should I keep that at the end? Like, will this work greedily? Okay. So the one which gives me maximum pairs, if I keep that at the end. Three gets paired up with these two, then we have 6. Then 6 gets paired up with that. Okay, so if I have a number, let's say x, then all of the numbers that are 2x, first of all, obviously the even numbers should be kept before, because like for the odd ones we are multiplying with them. I think if I just arrange them in a way such that I have even numbers first of all, then I have odd numbers. And not even odd, in fact, the ones that have the highest power of 2, I can keep them in front. Because then they have the chance of, coming up with other people as well. Okay. So I can arrange it in a form such that the maximum, such that the numbers with the maximum 2 key power, they come first. Right. Then what do I do? Okay. While a modulo 2 equals to 0. And I hope they don't have zeros here. They don't have zeros. Then I do count plus plus. Okay. GCD of ARR at I, comma 2 into ARR at j is greater than 1. Yeah, this should be fine. But let's see. It is all about keeping the numbers that have the highest power of 2 before them. Okay. Now what is the issue? Okay. Dot ss. Okay, I don't know why Sublime is taking such a lot of time. Maybe there is, okay, there is an infinite loop. Let's cancel build. $409, okay. And I hope I'm doing everything right. Let me look at the code once again. Okay, seems fine. Yeah, great. So moving on to problem C now. You're given a string S consisting of the character 0, 1 and a question mark. Let's call a string unstable. Okay, let me see if it is getting recorded here. Let's call a string beautiful if it consists of the character 0, 1, and you can replace the character to 0 or 1. For each character, the choice is independent so that the string becomes unstable. Let's call a string unstable if it consists of the character 0 and 1 and any two adjacent characters are different. Okay, any two adjacent characters are different. Achha, okay, all are different. Okay. Are beautiful and the strings are not. 0, 1. Calculate the number of beautiful continuous substrings of the strings. Okay, beautiful substrings. Oh, okay. So a substring is beautiful. Okay. So how many substrings can be beautiful here? We have to replace the question mark with a 0 or a 1. So if I'm starting my substring at index I and ending at index j, then there are two possibilities. Either I can start with 0 or I can start with 1. Okay. So if I start with 0, then all I have to find is the number of substrings starting from index I. Oh, this can be done with a DP, I think. Right. I think this is a very straightforward DP here, linear DP. Okay, we don't have this. Okay, dp at 0 comma 1 equals to 1, dp at 0 comma 0 equals to 1, right? Yeah. Okay, if s at I e question mark, then dp at I comma 1 equals to dp at okay, dp at I minus 1. Okay, dp at I minus 1 comma 0, dp at I comma 0 equals to 1 ll, dp at I minus 1 1. Okay, if it is a 0, then dp at I comma 1 equals to 0, dp at I comma 0 equals to 1 ll plus dp of I minus 1 I comma 0 equals to 0. Okay, this gives me 0 as the answer. Okay, have I taken the input? I have. Okay, okay, 11, 18 and 36. So I think there is an issue here. Okay, if s at I minus 1 equals to a question mark, then I have both possibilities. I have dp at I1 and okay, okay, let's try it out for the very first case. Let's see what are we getting. So I have 11. Okay, dp at, okay, this shouldn't be 1, right? This should be normal. Now I'm getting 9, which is not right again. So I have 0 and 1. This is fine. Then I have dp at I comma 1. If I place a 1 here, then I have 2 substrings, right? Yeah. If I place a 1 here, I have 2 substrings. If I place a 0 here, I only have a single substring. Okay. Now if I place a 1 here, then it is 1 0. If it consists of characters Okay. So are we not considering the strings that do not include that question mark? I think we shouldn't be adding a 1 here then. I don't know, what are they asking? If it consists of the characters 0, 1 and any two adjacent characters are different. Okay. Let's call a string beautiful if it consists of the character 0, 1 and this. And you can replace for each character the choice is independent so that the string becomes unstable. For example, are beautiful. Calculate the number of contiguous substrings of the string beautiful contiguous substrings. What about this? How does it have 6? Let's look at this one. Oh, okay. So you cannot end here, right? Okay, so I don't have to count them differently. That is the thing here. I think all I have to do is add the max of these two. Three, 6 and 11. Okay. So this should have been 1 LL plus now. Eight, 6 and 25 seems fine now. I'm submitting this. And I hope I do not have any integer overflows and all such stuff. Okay. Okay, great. So this was like a cool problem of DP. And also I think the problem statement could have been a lot, simpler. But yeah, that is how it is. Okay, moving to problem D now. Let's see how many submissions are there. 21 only. But there is like a lot of time to think about it, so I should be thinking about it properly. 2K teams participate in a playoff. The tournament consists of 2K minus 1 games. Okay. They are held as follows. First of all, the teams are split into pairs. Team 1 plays against Team 2. So 2K minus 1 games are played. Okay, so for example, here there are 8 teams, so 7 games were played. Okay. If only one team remains, it is declared the champion, otherwise 2k minus 2 games are played. In the first one of them, the winner of the... Okay. The process describes the chronological order of game with k equals to 3. Let the string consisting of 2k minus 1 characters describe the results of the games in chronological order as follows. If si equals to 0, then team with lower index wins the ith game. If si equals to 1, then the team with the greater index wins the ith game. Okay. If si equals to question mark, then the result of the ith game is unknown. Any team could win this game. Let fs be the number of possible winners of the tournament described by the string as. A team I is a possible winner of the tournament if it is possible to replace every question mark with either 1 or 0 in such a way that team I is the champion. Okay. You're given the initial state of the string. You have to process Q queries of the following form. PC, replace SP with character C. Okay. Cool. And why don't they have any explanations here? This is insane. Okay. So how many winners are possible? That is the question. Okay, so if there is like a 1 at a certain index, let's say this is 1, 2, 3, 4, fifth index, that means these two teams are playing. So if there is a 1, then the whole, this part gets rejected. Right, yeah. Okay, what happened to one node now? Okay, so if I have these, oh my god. So if this is the thing, right? So let's say this is character 0, this is 1, this is 2, right? So if character 0 is, let's say, 0, then I know that all of the teams above this are totally rejected, right? Okay, so for every node, if I can store... Oh my god, this is insane. How do I process this? So for every node, all of this stuff is coming, right? Yeah. So if I look at it in a reversed order, like if I look at this like this, then this goes something like this, and it is something like a binary tree if I process it in the reverse order. Then what do I know? That if this character is, let's say, question mark, then the total number of teams that can reach this point and the total number of teams that can reach this point all are winners, right? Yeah. Okay, great. If this is a 1, then what do I know? Um, the team with the lower index wins. Okay, so let's say this thing is the lower index. And how do I look at it? This one will come first and this will come later. So if it says 0, then I have to team with the lower index wins in this case. So which is the lower index? This is the lower index. So I just look at this one. And if it tells me that, this is the point, then I'm done as well. But how do I keep this information? And how many levels are here? Like how many nodes are here? The nodes are 2 to the power k minus 1. There are very many nodes here. Okay. Yeah, so if I look at it in a reversed order, then it is a binary tree. And if this is a question mark, I can ask the answer for this one and this one. So at each index, if I can store the number of so game 1 and game 2 are linked with game 5. Game 3 and game 4 are linked with game 6. Right, yeah. What else do I know here? And there are like many queries. Update and okay, after each query I have to find the answer. Right. So if I consider it like a binary tree, let me think about this. Okay, so I can treat it like a binary tree for sure. And again, I can, solve it like a DP. Okay. Okay. So now I need to do the pre-processing. Okay. So I have 0 here, and then what else do I have? Okay, let me turn off the charging. Yeah, so I only have to pass in 0 here. Also, I can solve it from back to forward. So how do I check if it is a leaf node or not? Int x equals to I into 2 plus 1. So this will be like its left child. And this will be its right child. So when I talk about the left child, it contains the indices. It contains the smaller ones. Does it contain the smaller one? No, it contains the larger ones. Okay, so if x is less than k, okay, if x is less than k, not a leaf node, then what do I do? If it is not equal to question mark, then what do I do? Then I know dp of I, and yeah, this is fine. Else, if s at I question mark, then all are possible winners. Then what do I do? But still, like, what do they mean by a question mark? The result of the ith game is unknown. Yeah, they can win, right? dp at y. So if s at I equals to a 1, then I know the bigger ones are winning. So dp at I equals to dp at x, else dp at I. dp at I equals to y. Also, I can maintain a vector here. From E6 0. Okay. Okay, let's try it out. I will have to handle the queries later, but first I'm seeing if I'm getting the right outputs or not. Okay. So if what is the string exactly? It is 1. Okay, let's look at it like this: 0, 1, 1, 0, and then they have a question mark, and then they have a 1, and then they have a 1. Right? Yeah. So this is 1, this is 1, this is 1, and this is 1. Now if this is a question mark, then this is 2. Both of them are possible. This is 1. Okay, now let's try to replace this with a question mark. Will the answer be 3? It should be 3. Okay, great. Now what do I need to do? And how do I find the parent here? Okay. S at index equals to ch, index minus minus. So now I again need to calculate the answer. If I'm standing at the top node, I need to get to this index, right? Yeah. Okay, so it is more like, a heapify type of a thing when we have a heap here. So helper at 0 comma index. Okay, so if I into 2 plus 1, so how do I calculate the range now? Now this is another issue. It is just like a segment tree. Let me think about it. Okay, I can do it in a totally different way as well. While index is So now it is the same thing. So this is x, this is y. Okay. So if x is less than k, this is the thing. Okay. Then what do I need to do? Okay, this is fine till here. Then I do index equals to index minus 1 by 2. Right here. And for 0, I will calculate it on my own. So I can do this again. Right, let's see. Set I. Okay, there is some other issue. Okay, helper. So I have 1, 2. Okay. Let's see what was the issue that we did not get an answer. Okay, I had to, reverse it. So the index actually changes here. Right here. So the answer is not coming fine in the second last case. So let's try to, debug the string. So we know exactly what is going on. So first it said to convert it to this, then it said, oh, 6 2, okay, 1. Then it said 7 question mark. But this did not happen, right? Okay, it actually did happen. 7 got this, 5 got this. Okay, let's try to see from this point what is the answer that we are getting. So it is a question mark 1 1 0, then question mark and question mark. So here the answer was 2 2 1 1 1. So here the answer is 2, and here what is the answer? Here the answer is 3. Right. Now what else do I need? I need the DP as well. Okay, and I will do this CR. So here it was 1 1, 2 1 and 1. Okay, now we have 1 1 1. Now it says 1 1 1. Okay, how is the answer coming out to be 2 here? That is the issue. So if it says question mark, oh, if it says question mark, then both are possible, right? Now this is 2 comma 1 comma 1, and then this should have been 3, right? Okay, and x equals to this, y equals to this. So if x is less than k, x is less than k, this should have been x is less than n. Okay, now it seems to be fine. And if you talk about the time complexity, here it is log n. Let's just keep that and not call this function ever. Okay, let's see. So there are 10 to the power 5 queries, and for each we are doing a login work. So this should be fine. Let's submit this. Okay, wrong answer on test 2. Let's see if I'm doing something else wrong here. Okay, and is this length of the string n minus 1? I don't know, like this seems like a very standard binary type of a question. N equals to s dot length. So if this is less than n, y should also be less than n, right? Okay, let's try to see what are the I values that you're getting. I equals to 2. Okay, the others are loop nodes. This is fine. What if I just have 4? I mean, and this is the thing. Okay, so here I'm getting the answer as 2 to the power k minus 1. Okay, fine. Oh, just a minute. But I am getting the answer as 2, right? This should have been less than n first of all. This was a blunder. And how is it giving the answer as 2? This should have been dp at y. Okay, let me read the code once again. Okay. So this is x, this is y. S at I equals to question mark, then dp at I equals to dp at x plus dp at y. If it is equal to this, then dp. Okay. If we talk about the queries, then it is the same. I do this. Same thing. Okay, again same thing. Okay, let me check the code once again very quickly. dp at I, this is fine. K and S, then I do N, then I have this. If it is, so what if I have something like, okay, this is fine. If this is less than N, then that has to be less than N again. So S at I equals to question mark, then dp at I equals to dp at I, x plus dp at y. Okay. Same thing. So now this seems fine to me. Let's submit it again. Okay, great. So there were like many typos, and I don't know, I was not missing out on any logic if you look at it that way. So great, we're done with 4 questions. I can still try out the 5th one because there is an hour left. Okay, a tree question, great. You're given a rooted tree where each vertex contains AI tons of gold, which costs CI per 1 ton. Vertex I will have AI tons of gold with CI per ton. It's guaranteed CI is greater than C of C at P at I. Okay, that means you have to increase the cost every time. Okay, for a vertex Vi, consider a simple path from Vi to the root. We need to purchase Wi tons of gold from these vertices on this path, spending the minimum amount of money. Okay, so it is always better to choose the, you know, root node as one of them, because that will obviously contain the least cost. We buy all we can. If we buy x tons of gold in some vertex V, the remaining amount of gold in it decreases by x. Of course, we can't buy more gold that the vertex has at the moment. For each query of the second type, calculate the resulting amount of gold we bought and the amount of money we should spend. Note that you should solve the problem in online mode. It means that you cannot read the whole input at once. You can read each query only after writing the answer for the last query. Okay, this is like a nice way to make people do online queries. Just make the question interactive and you're done. Okay. Okay, so when it decreases, like, does it decrease for the whole thing? Add vertex I. Of course, we can't buy more gold that for each query of. Okay. So first we have the root node, which has like 5 gold and 2 per cost, 2 per a ton of gold, and then we ask for the query and it says 2 comma 4, right? Three, okay, 3 tons remain in the root. We add vertex 2 as a son of, okay, and has 3 tons of gold with price 4 per ton. With price 4 per 1 ton. Add vertex 2. Okay. Okay. At the second query, we add vertex 2 as a son of vertex 0. How are they saying vertex 2? Add vertex I. Oh, okay. Okay. Add vertex 2 as a son of the vertex 0, and then add vertex 2 and which has 3 tons of gold, and it has 4 per ton. The next query tells us to buy 4 tons, so we buy it from the first one. Then we path from 2 to 0 consists of only 2 vertices, 0 and 2, and since C of 0 is less than C2, we buy 3 tons of gold in vertex 0 and 1 ton in. Now in vertex 0, no gold left, and 2 tons of gold remain in the vertex 2. 2 tons, okay. This is interesting. And we need to find the minimum answer every time. Okay, I will have to think about this. Okay, let me think about this. Okay, so like I kind of have an approach for this, and it will work in n, I mean q into log of q square, log square of q. But that might be too heavy in case of, okay, that is not too heavy in case of this interactive problem because we have 4.5 seconds. Okay, so I will be doing binary lifting here. Okay, so let me just check 2 to the power 22. Okay, it is way higher than that. So we have max n, then I have limit. Okay. Max n. And I will also need a map here to store everything like that. Okay, should I be having a map here? That is another question. Okay, I don't think I will be requiring a map here. Okay, so what do I have here? I will have values. Values at 0 equals to a, comma b, right? Yeah. And all of the parents are already defined. So while q minus minus. So first of all, we take the type. Okay, so if type equals to 2, so that just means we have to calculate the value, right? Int index and w, right? So now what do I have to do? I can take ll as well. Okay, so here I have to find okay, int index int llw. So this I will do. Okay, helper 1 index and w, else I am getting a new node here, right? So int node, right? Now what do I do? Now I have to insert it, right? So I can also have edges here. Okay, so now I will have edges at node, sorry, edges at I also need the index, right? So I have edges at i.pb node, then I have for int j equals to 0, j is in fact this. I can keep the limit as 25 also, it does not matter here, right? Parent at node, zero equals to I, node at I equals to I minus 1. If x is not equal to minus 1, parent at node at j, sorry, this should have been j, parent at x comma j minus 1, else you break. Okay, now we're done with this part. So this is cool. Now all I have to do here is complete this helper function. Okay, so for int I equals to limit so what do I have to do here? I have to find the first value if parent at index comma I is not equal to minus 1 and then parent at index comma I dot, okay, int x equals to parent at index comma I, right? If x is not equal to minus 1 and okay, the values are till 10 to the power 6. Yeah, this should be fine. Node 2 equals to index. If x is not equal to minus 1 and then parent at index dot ff is greater than 0, then what do I do? Index equals to parent at index at I, right? Yeah. Now what do I do? While w is greater than 0 and index is not equal to node 2, right? Yeah. Okay, so while the sum is greater than 0, else what do we do? Else we are on this node, right? Yeah. Else x equals to values at node 2 dot. Okay, I also have to go in that direction. This is another thing. Yeah. Okay. So this I will have to do multiple times. Yeah, this should be fine. This I have to do multiple times. That is why it is log square n. While w is greater than 0. Okay. So you found the index that is that has the value greater than 0. Then what do you do? Values at index dot ff. Okay. So min x comma w plus equals to p, answer to plus equals to p into values at index dot ss. Values at index dot ss. Okay. Right. So here what do you do? If yeah, this should be fine. Let me check my code once again. So while w is greater than 0, I also have to do w minus equals to. Right. This is the amount that is present. I calculate the minimum of these two. Then I do answer 1 plus equals to p, answer 2 plus equals to p into values at index dot ss. Yeah, this should be fine. And I don't know if log square n will work or not here. So I hope I don't have many errors. Oh, okay. Okay, now I have to test it. So let's test it. Right. So I have 2 comma 0 comma 2. It prints 2 comma 4. Okay, 1 comma 0 comma. It does nothing. Okay, 2 and 2 and 4. Okay, now is the issue here first of all. So let's try to test this. Oh. So if index 2 equals to node 2. Okay. Can I put the input directly here? Will that work as well? I think it should. Because this is like just queries, right? So I have 2 comma 4 0 comma 0. Okay, what else do I need to take care of? Let's try to debug. So I have 0 comma 2, then I have 2 comma 4, then I have 4 comma 2, right? So I equals to limit minus 1, I is greater than or equal to 0, I minus minus. Int x equals to parent at index comma I. If x is not equal to minus 1 and values at x dot ff is greater than 0, index equals to x. Okay. Debug index. So first it went to 0 and here it went to 2 because all of that is already empty, right? Okay. Parent at node comma 0 equals to I. Instead it should have been edges at I. Oh, node.pbi, right? Yeah. Then what do? Edges at node.pbi, edges at I equals to node. Okay, let's see this now. So I have 4 comma 0. Values at node. Four comma 13. Why is it going to 0 again? Oh my god, this should have been it. I'm getting 4 and 10 and there I'm getting 3 and 12. Oh my god, what is this now? Let's close this and let's see how much time is remaining. 28 minutes. Okay, this is still doable. I just have to focus a little here. So 3 were left, that is fine. Okay. Why is it coming out to be 0 and 0? Should have. Okay. 4 comma 10 and 1 comma 3. Okay, seems to be working. So let's try to submit this now. Okay, I hope I don't get a TLE. Runtime error. Where can I get a runtime error? Let's try to see. So file w is greater than 0, index equals to node 2, x equals to parent at index comma I. If x is not equal to -1 and then values dot x is dot ff is greater than 0, index equals to x. Okay. Debug index. Is there some issue here? No, I don't think so. LLX equals to this, LLP equals to this. Minimum of x comma w. Answer 1 plus equals to p. Answer 2 plus equals to p into values at index dot ss. Okay. Values dot at index dot ff minus equals to p, w minus equals to p. Now if index equals to node 2, then you break. Right here. Okay, that is clear. This is fine. Here I have q, a, b. Values at q equals to a comma b. I equals to 1. Type, if type 2 equals to 2, then I have index w and I have index and helper. Okay, fine. Otherwise I have node a and b. So what do? I take the node as the input and I put this edges at node.pbi. Actually, I don't need this. This is never used. So this is fine again. Runtime error. Why am I getting a runtime error? Next, what do? Parent at I comma 0 equals to node. This is fine. J equals to 1. J is less than limit j at x equals to parent at I comma j minus 1. If x is not equal to -1, parent at node comma I. This should have been node comma j, right? Yeah. Equals to, oh my god, I get it. Okay, am I getting a runtime error again? Wrong answer on test 2. Also, oh my god, this should have been I, no. I don't know like how do these sample test case work every time. Let me test it once again. There is no need to submit so quickly. Parent at I comma j minus 1. Okay, now it seems to be fine. Okay, test case 12. Come on. I think it should work now. Yes. Yes, yes. Great, great. So like I should drop down to somewhere about 300 because I have 2 penalties here. But this was a cool question on binary lifting. Okay, I don't think I will be able to solve any further questions. So I will be ending it now. And what is the time limit here? The time limit is 4.5 seconds. And what is the memory that my code is using? 44 MB. So it should be fine. Like, I think it is running in the worst case only. Yeah. So yeah, I will be ending it now. Let me look at Codeforces predictor. Okay, plus 71 it is showing when I have a rank of 344. And I kind of have a much better rank right now. Okay, yeah, so I will be ending it now.